Alright, so we are still on the concept of equilibrium of forces, specifically triangle of forces, triangle law of forces. So it says, the question says the body P shown in the diagram below is in equilibrium. If the mass of the body is 10 kg, calculate the tension T in the string. Acceleration to gravity is 10 meters per second square. And then this is the diagram. So this is a body P. We have to look for the weight of that body. Since the mass of the body is given to us as 10 kg, okay, now we look for the weight. The weight there is, okay, so we look for the weight of that body. Let's say if this is the body, its weight we act vertically downwards. This weight we act vertically downwards. That is W is equals to mg, right? Which is this will be equal to m is 10 kg. 10 kg and g is 10 meters per second square. So if I multiply them, 10 times 10 will give me 100. My weight, the weight of that body is 100 newton. The weight is 100 newton, okay? So at this point now you take your tension force T, which is inclined at an angle 60 degrees with the vertical. 60 degrees with the vertical. And at this other point you take the line going this way. That is the force F. Okay. So we have this, the weight of that body acting vertically downwards as W equals to mg, which is 100 newton, and the tension force going this way. It implies that here you have, this is 90 minus 60, so this side will be 30 degrees. Okay, that's 30 degrees. Okay, and at this side we'll be having 90. This is a right angle 90. Okay, so these are the forces T, the weight W, which is 100 newton, and this force F. And what we are looking for is tension in the string. Okay, so we come back here now. It means that if I extend this line, this can also be extended like this. 30 degrees we alternate here as 30 degrees. 60 degrees we also alternate as 60. Okay. Alright, so I'll first take my weight acting vertically downwards. Okay, so using the triangle of forces, I'll take the weight that acts vertically downwards, the weight of the body acting vertically downwards, which is W, equals to 100 newton. Okay. Then the next thing I'll take is the force. I'll take this force going like this. Okay. I'll take the force going this way. The force going that way is force F. Okay. And then I'll take the tension. This is the direction of the tension force. Tension force is going like this. So I'll take it. And then you also take note of this angle 60 degrees. That's this alternating here, 60 degrees. So I take the tension force, taking my tension force going like this, and the angle there is 60 degrees. Okay, angle is 60 degrees. Alright, call this tension T. Okay, so this is what we have gotten using the triangle of forces. So it means that the angle here, 90 minus 60, here will be 30 degrees. Okay, and then if I extend it here like this, 30 degrees, here is also 30 degrees, and this angle here will be 60 degrees, and here is 90. Here is 90 degrees. Okay, so you can then solve that. You can say here is point A, here is point B, and this is point C. So you're having a right angle triangle. Okay, having a right angle triangle, and what we have to look for is T, isn't it? And to look for T now, you simply use your trigonometric ratios. In this case now, sine theta, what's it called? Sine rule. Sine rule will not work here. So what will work is your trig ratios, because this is a right angle triangle. Okay, so say using your trigonometric ratio, using the basic trigonometric ratio, That's Asuka Tua. So let's assume that you are making use of this angle 60 degrees. So the opposite side is this. If you are making use of this angle of inclination, the opposite side is this, and the adjacent side to this angle will be this. Okay, and the side facing 90, angle 90, is hypotenuse. That's the longest side facing 90 degrees. Okay, so what we just need is to find this, and we have this side. So we have adjacent and hypotenuse. So what I will use now is cos. So it means that cos 60 degrees, use this. Say cos 60 degrees is the adjacent side over the hypotenuse, and my adjacent side in that diagram is W, which is 100 Newton. That's 100 over the hypotenuse is T, tension T. Okay, so if that is the case, now I can then cross multiply. So this will multiply this, and I'll have T cos 60 will be equals to 100. Okay, so I divide by the coefficient of T, that's cos 60. So T will be equals to 100 divided by cos 60 degrees, and this will be equals to 100 divided by cos 60 is 0.5. Okay, so this now will be T equal to 100 divided by 0.5. So T is equals to 200 Newton. That's the tension. Tension T is 200 Newton. Okay, now let's look for force F. Let's look for F. So this now will be opposite over my hypotenuse, or you can say opposite over adjacent. That's tan. Tua we go now for this case. So to find tan force F, say tan 60 degrees is the opposite side over the adjacent side, and the opposite side is F. The adjacent side is W, which is 100 Newton. Okay, so if I cross multiply, this will multiply this, and I'll be having that F is equal to, so F is equals to 100 tan 60 degrees. Okay, so F now will be equals to 100 times tan 60. Tan 60 is 1.732. So if I multiply it now, F will be equals to 100 times 1.732. This will give me 173.2. Okay, so that is F. F is 173.2, and this other one, tension, give us 200 Newton. Alright, let's look at this question, example 5. This is the diagram we have there. It says a body of mass 0.5 kilogram is suspended by a string and pulled by a horizontal force of 12 Newton. Okay, as shown in the diagram above. Calculate the tension T in the string if the body is in equilibrium. We are given the value of acceleration due to gravity as 10 meters per second square. Okay, now this is the tension acting here along this rope, and this is the body. That's the mass of the body. The force is acting this way on this other string, 12 Newton. The weight of the body is acting vertically downwards. So if we redraw this diagram now, it means that we'll be having, okay, it means we'll be having something like this. This is the body, and then the weight will act downwards. Say W is equals to mg. The mass is 0.5 multiplied by 10 meters per second square. If I multiply that now, I'll be having 5 Newton as my weight. Okay, so the weight is 5 Newton. Then you come over here, you draw the force T, horizontal force F, which is 12 Newton. And then you also take the tension going that way, that's a diagonal line, acting diagonally, that's tension force T on this other string. Okay, so we use the triangle of forces to solve. Using the triangle of forces, the first thing you take, first take this vertical force, and you'll be having, so I'll first take the vertical force, and it will act this way. The vertical force is acting this way, acting vertically downwards, which is the weight. weight, we have the weight as 5 Newton. Then I take my tension force going like this. Tension force going like this. This is the tension force. And tension force is tension force, you have tension force T. Okay, and then you also take this other horizontal force, this one, that's 12 Newton horizontal force. So you have something like this. The weight will act vertically downwards. The weight of the body which is acting vertically downwards, that's this. We took it first. That's this one. Take this one first. Then secondly, take this other one. Then you take this one. So taking the weight acting downwards, you have something like this. W, which is 5 Newton. Then you take this tension force T to go like this. Okay, so I have this tension force T is this going this way, and then I'll take the 12 Newton force going horizontally. Okay, alright, so I'll have something like this. I'm having this 90 Newton, 90 degrees, sorry, 90 degrees, and this is the head or the tip of this force. Then this is the tail of this other one. This is the tip. This is the tip of this. This is the tip of this other one as well. It should be here. Okay, that is tip to tail. Yeah, tip to tail, tip to tail, tip to tail. Okay. So what we do now, we just simply use Pythagoras rule. Using Pythagoras rule or Pythagoras theorem, you find this. This is a right angle triangle. So using Pythagoras theorem, using Pythagoras theorem or rule, we're having the hypotenuse square is equals to the opposite square plus the adjacent square. So if I assume that an angle of inclination is here, for instance, this will be my opposite side, and the longest side facing 90 degrees is my hypotenuse side, and this is the adjacent side. So Pythagoras was actually stating a theorem that for a right angle triangle, the square of the longest side is equal to the sum of the other. The square of the longest side is equal to the sum of square of the other two sides. And the other two sides are opposite and the adjacent. So this is the square of the longest side, which is the hypotenuse. The hypotenuse is T. So I'll write T out. That is T raised to the power of 2 is equals to the opposite side. Opposite is W, which is 5. That's 5 raised to the power 2 plus the adjacent is 12, which is 12 raised to the power of 2. Okay, so T square will be equals to 5 raised to the power 2 is 25, and 12 raised to the power 2 gives me 144. When I add them, I'll be having that T square is equals to 169. Okay, so T now, the square root, taking square root of both sides, that's T raised to the power half equals to 169 raised to the power of half. Okay, so I'll be having this, we eliminate this, and T will be the square root of 169. So T is 13 Newton. Okay, T is equals to 13 Newton. Okay, so take note to the square root of both sides, and we finally had that T is 13 Newton. 13 Newton. That's the tension force. Alright. Okay, so take note, we got the tension using Pythagoras theorem, and we had it as 13 Newton. Okay, alright, we have another question on the board. It says the diagram above illustrates 3 forces T1, T2 and 100 Newton in equilibrium. Stop. Determine the magnitude of T1 and T2. Okay, so this is the diagram. This shows us the body. The weight of that body is 100 Newton, and tension acting along this side is T2. Tension acting here is T1. Okay, So what we simply do now is to take to draw the triangle of forces using these forces given to us. Of course, we should know that this is 90 degrees. Okay, and then use dotted lines, extend this. You have this as 60. Here is 60 degrees as well. Okay, so if I take that out now, I'll first take the weight acting vertically downwards. So taking my weight acting vertically downwards, I have the weight here that acts vertically downwards, and this is W, which is equals to 100 Newton. Okay, that's the first step. Then I'll take tension T2 going this way, and it's inclined at 30 degrees to the vertical. Sorry, inclined at 30 degrees to the vertical line. So I'll take it, and I'll be having tension T2, which is inclined at 30 degrees to the vertical. Inclined at 30 degrees to the vertical. So this is T2, and then the next thing I'll take tension T1 on the horizontal line like this. Take it out. Now I'll be having tension T1. Okay, so I've succeeded in joining them. Then that means here will be 90 degrees. That's tip to tail, and tip to tail. Okay, so you agree with me that this is a right angle triangle. Okay, so the side facing this angle of inclination now is my opposite side. Okay, and the side facing angle 90 is the hypotenuse. Alright, and then this remaining side becomes my adjacent. This remaining side becomes the adjacent side. Alright, okay, so this hypotenuse is the opposite and this is the adjacent. Alright, so now the next thing I'll do now is I'll use my trig ratios. Of course, this side should be 60. This side is 60 degrees. So using the trigonometric ratio now, so using the trigonometric ratios, I've explained that before. That's so ka twa. That's the trig ratios. Okay, so let's look for this. If I say opposite over adjacent, that's tan. So that is tan 30 degrees will be my opposite side over the adjacent, and the opposite side is T1. The adjacent side is W, which is 100. So I'll cross multiply this to multiply this, and the T1 is equals to 100 tan 30 degrees. Okay, T1 is 100 tan 30 degrees, and that will give me, if you have to use solving with sort form, you say, because that if you have something like this, this is 30 degrees and this is 60 degrees. Over here is root 3, here is 2, and this is 1. Okay, so tan 30 now, the opposite side of 30 is this. So you say tan 30 is opposite over adjacent, and that's 1 over the adjacent side is root 3. 1 over root 3. If I rationalize it, I'll be having 1 over root 3 times root 3 over root 3. Okay, and 1 times root 3 will give me root 3. Root 3 times root 3 is 3. So this will be equals to root of 3 over 3. That is tan 30 degrees. Tan 30 degrees is root 3 over 3. Okay, and then come back here, that T1 is equals to 100 times tan 30 is root 3 over 3. Okay, means that T1 is equals to 100 100 root 3 over 3 in newtons. Okay, that's T1. Alright, but then if you choose to solve it in using decimals, you say that T1 is 100 tan 30 degrees. Okay, 130 degrees means that T1 will be 100 times tan 30 will give us 0.5774. Okay, so when I multiply that now, when I multiply this, I'll be having 100 times 0.5774 will give me, I'll be having T1 as 57.74 Newton. Okay, alright, so that is it. T1 is 57.74 Newton. That's when I multiply with 100. Multiply by 100. So to find T2 now, this is adjacent side and this is the hypotenuse. So I can say adjacent of hypotenuse, which is cos 30. Say cos 30 degrees is equals to adjacent over the hypotenuse. Okay, adjacent of hypotenuse. So this now will give me my adjacent side is 100 and the hypotenuse is T2. So if I cross multiply, this will multiply this T2 multiply this one, that's T2 cos 30 degrees is equals to 100 and divide by cos 30, that's T2 equals to 100 over cos 30 degrees is equal to 100 divided by cos 30. I'll check that. Cos 30, the cosine of 30 cos 30 degrees is the adjacent side of 30 is root 3, and then the hypotenuse of it is 2, that's root 3 over 2. So half this is equal to root 3 over 2. Okay, so T2 will be equals to 100 divided by so I'm having 100 all over 100 over root 3 over 2, which is 100 divided by root 3 over 2 will give you 100 times this 2 will go up, this one will come down, that is times 2 over root of 3. This will give me, this is 100 times 2 is 200 over root 3. Okay, so I will then rationalize it, and by rationalizing 200 root 3, that will be, so this now will be, say T2 is 200 over root of 3 times root of 3 over root of 3. Okay, this will be 200 root 3. Root 3 times root 3 is root 9, and square root of 9 is 3. Okay, Newton. This is tension T2. Or if you say cos 30 degrees is the adjacent side over hypotenuse, which is 100. The adjacent side is 100. Hypotenuse is T2. That's 100 over T2. So if I interchange position now, T2 will be equals to 100 over cos 30. Okay, so T2 now will be equals to 100 divided by cos 30 is 0.866. So this now will be equals to 100 divided by 0.866. This will give me 115.47 Newton. Okay, that's T2 115.47 Newton, or 200 root 3 over 3. Okay, we have T1 as 57.74 Newton. Okay, so that is it. We'll be stopping here for today. Thank you very much.